Hello students, welcome to lecture 12 of chemistry online classes. I have given you one question for percentage composition of element, but before that, after solving the questions of mole concept, we have seen what we mean by empirical formula and molecular formula. Empirical formula is the simplest formula which gives relative number of atoms of different elements present in a molecule of a compound, and the molecular formula is the true formula which gives actual number of atoms of different elements present in a molecule of a compound. For example, molecular formula of benzene is C6H6. Empirical formula is CH. Molecular formula of hydrogen peroxide is H2O2. Empirical formula is HO. Because we have to take the relative numbers of atoms present in a molecule. To calculate this empirical formula and molecular formula, we should know percentage composition of the element. And how it is determined? The formula is mass of element divided by the molecular mass of a compound multiplied by 100. We have solved some 3-4 questions together, and one question I have given you as homework. The question was, in hydrogen peroxide, the question was, hydrogen and oxygens are combined in the ratio of 1:16 by mass, means contribution of hydrogen is 1 and that of oxygen is 16, in together 17, because if we add hydrogen and oxygen mass, which is 17, and contribution of hydrogen is 1. What is the contribution of oxygen? 16. So we can easily calculate the percentage of hydrogen and oxygen here. 17 parts. 17, from where we are getting this 17? 1 part of hydrogen and 16 parts of oxygen. Together 17 parts of hydrogen peroxide. It contains 1 part of hydrogen. That's what they have provided in the question. Percentage of hydrogen is equal to mass of hydrogen divided by the total mass of that mixture, which is 17. 1 by 17 into 100, 5.88%. You can simplify it, 100 by 17. Percentage of oxygen is equal to 16 by 17 into 100, and it happens to be 94.12. And when we add together, they becomes 100%. So this about the percentage composition questions. Then lastly, in the last class, the last part, we have seen what are the steps to be determined. What are the steps to be used to determine empirical formula, molecular formula. We have listed all 10 steps. First is, we should know percentage composition of element, which is given in the question. 93.71% of carbon, 6.29% of hydrogen, which will be given in question. Next is atomic mass, that will be given in the bracket at the end of question. What are the atomic masses of those elements which are mentioned in that particular question? So percentage of element, atomic mass, then we have to calculate the relative number of the atoms. How it is calculated? Percentage divided by atomic mass. The next is simplest ratio. It is nothing but relative number of atoms divided by the smallest number in step 3. I have solved question. Once again I will repeat. It will be a serious question. And then next is simplest whole number ratio. If we get fractions it is to be multiplied by suitable integer to make it simplest whole number ratio. Once we get that simplest whole number ratio, we have the empirical formula, because empirical formula is nothing but symbol of element and subscript in the form of simplest whole number ratio. So empirical formula is determined. Next is determine empirical formula mass. How to determine it? Sum of atomic masses of elements present in an empirical formula. Then molecular mass will be given in the question. Use formula small n equals to molecular mass divided by empirical formula mass. Get the value of n. And lastly, molecular formula is equal to empirical formula multiplied by that integer n. We have to solve few questions on it, because in theory examination the most frequently asked question is determine empirical formula and molecular formula. In MCQs also it has been asked. So I have given one question. I will explain this question, and next few questions we will do together. Only to save time, I already written here, so that you can write the question and you can pause the video and then see how we have solved. So the question is the molecules insect repellent organic compounds. It contains 93.71% carbon and 6.29% hydrogen. So here they are given elements carbon and hydrogen, and their percentage 93.71 and 6.29. Molecular mass is also given 128 gram per mole. To calculate its molecular formula. To get the molecular formula, we should first calculate the empirical formula. So I have to make one table here, and all steps are to be followed. In column number 1, element, only 2 are there. If more than 2 are there, we will go on adding this. But when we read question, the elements are only carbon and hydrogen. Next is percentage of these elements. 93.71, 6.29. Atomic mass of these elements, carbon 12, hydrogen 1. This they will give in bracket. Now we have to remember some atomic masses. There is no harm in remembering at least few elements atomic masses, which are frequently we use in these calculations. Relative number of atoms is nothing but percentage divided by atomic mass. Percentage is 93.71 divided by 12. It happens to be 7.809, and 6.29 divided by 1, 6.29. Now I have to look into these two numbers, 7.809 and 6.29. 6.29 is the smallest one, so I have to select that. And what is the use of this? We have to divide all numbers in relative number of atoms with this number. So relative number of atoms for carbon was 7.809. We are dividing that number by 6.29. We are getting 1.24. Yes, you can do the calculation with simple calculator, and you will get the same answer. And this 6.29 is again divided by 6.29, because for every number we are dividing it by 6.29. So that happens to 1, because 6.29 divided by 6.29 equals to 1. Then this simplest whole number ratio is not whole number, 1.24 is not whole number. We have to convert that into whole number, because atoms are present in a molecule in whole number, they cannot be in fraction. So 1.24 into 4 is 4.98, which is, we can take it as 5, we can round it off. as we are multiplying it by 4, this 1 also should be multiplied by 4. Remember, we have to multiply with the same integer, then only our answer will be correct. Why we cannot multiply by 2? Because if we multiply by 2, 2.48, which is again not the whole number. 3 also, maybe 3.72, which is also not the whole number. 4.98. 4.98 can be rounded off to 5. That's why we have multiplied it by 4. We get it 5. And as 1.24 is multiplied by 4, 1 also has to be multiplied by 4. So 5 and 4 are the simplest whole number ratio of carbon and hydrogen. So empirical formula is equal to C subscript 5. Why 5? Because for carbon, simplest whole number ratio was 5. And for hydrogen, simplest whole number ratio was 4. So C5H4 is our empirical formula. Next step is calculate the empirical formula mass. 5 into atomic mass of carbon plus 4 into atomic mass of hydrogen. 5 into 12, 60. 4 into 1, 4, 64. You can write it as gram per mole, that doesn't matter here. Gram per mole. Then we have to calculate N here, N. Molecular mass divided by empirical formula mass. Molecular mass is given in questions. 128 gram per mole. Divided by 64. That happens to be 2. The molecular formula is equal to empirical formula into N. Empirical formula is C5H4 multiplied by 2. And that 5 into 2 is change. So C change. 4 into 2 is 8. So H8. That is our molecular formula. So many steps are involved, but not at all difficult. These steps are, if you practice it in a proper way, you will remember it. You will solve many more questions. Just one I have written here. We will go for the next question. We should be very alert in solving this type of questions. Now there is one more way to solve this question, but in theory examination you solve by this method only, because in theory examination the question paper center has given one specific key, and in key these steps are to be followed. But in MCQs we can have a shortcut method for it. I will solve by that method also, because once you understand that method, one more way of getting this question is known to you. So we can say, or but in theory examination is solved by this previous method only. I have told you already also, because that is only the acceptable method. This is shortcut method, you can use it in MCQs. So indirectly number of moles of carbon you can calculate. That is nothing but percentage of carbon by 100 multiplied by molecular mass of compound divided by atomic mass of carbon, because we are calculating number of moles of carbon. Percentage of carbon is 93.71 divided by 100. Molecular mass is 128 and atomic mass of carbon is 12. You just solve this and we get 10. If we get 9.99, we can round it off 10, because the number of atoms of carbon cannot be 9.99. It is to be whole number. Similarly, number of moles of hydrogen divided by 100 molecular mass of compound divided by atomic mass of hydrogen. Percentage of hydrogen is 6.29. 100 molecular mass is 128 by 1, and if we do this calculation it happens to be 8. That's why we can say molecular formula of compound is equal to C10H8. We get the same molecular formula by previous method also. In the form of table we have made, we get the same answer. Right, so you can use this in 2 steps. You will get this, if there are 2 elements, 2 steps, 3 elements, 3 steps, like that. What is needed for that percentage of element? Definitely given in the question. Molecular mass and atomic mass. Molecular mass also will be provided in the question. All data will be given. Only you have to understand concept, apply formula, calculate patiently, and you will get the correct answer. Right. So this is also one of the way. We will not apply this method to all questions, but you yourself apply it. We will do only by previous method. But whenever possible, you use this method and see whether your answer is correct. It will be always to get the same answer by both the methods. Right. Now we will go for next question. This question number 2 now, in case of determination of empirical molecular formula. See the question number 2. Calculate the empirical formula. They ask only empirical. Calculate the empirical formula of compound that contains 26.6% potassium, 35.4% chromium, and 38.1% oxygen. Right. And they have given atomic mass of potassium as 39.1 and that of chromium is 52 and oxygen is 60. Right, so this information is before us. We use this information, we will make the table in the form of element, percentage, atomic mass, relative number of atoms, then simplest ratio, and then simplest whole number ratio. Right. Practice it, then only you will understand these steps. So first element is potassium K. Percentage they have given is 26.6. Atomic mass is 39.1. The relative number of atoms is 26.6 divided by 39.1. We first just arrange this and then we'll solve it once. This is chromium. Percentage given is here 35.4. Atomic mass is 52. Relative number of atoms is percentage of element by atomic mass by 52. And then oxygen percentage is 38.1. Atomic mass is 16. Relative number of atoms is 38.1 by 16. Right, so 26.6 divided by 39.1, we get 0.68 here. 0.68. You also do yourself. Verify. This is also 0.68 only. And 38.1 by 16 is 2.38. So smallest number here is, yes, both of these, any one you can mark. 0.68. So 0.68 divided by 0.68. 0.68 divided by 0.68, because here also we get the same number. It is to be divided by the smallest number of this column. 2.38 divided by 0.68. This is 1. This is also 1. And 2.38 divided by 0.68 is 3.5. Now this is not the whole number ratio. Multiplied by 2, it becomes 7. But this also has to be multiplied by 2 and this also has to be multiplied by 2. So in the last column, by 2, we are multiplying simplest ratio with suitable integer. This is 2. This is also 2. 1 by 2. 1 multiplied by 2. And this is 3.5 multiplied by 2. It's 7. 2, 2, 7. Now last step is we have to calculate the empirical formula. And we can write empirical formula as empirical formula is equal to K, the subscript is 2, Cr2, and the oxygen is 7. Yes, this is our answer. They have not asked us to calculate the molecular formula, only empirical formula they have asked us. So this answer is sufficient, right? So this is question number 2 we have completed. So just write this question clearly and try to understand every step, because you have to use it when question is before you. Now I write here question number 3 here. Compound on analysis. Compound on analysis is found to have is found to have following composition. Following composition. A. Sodium 14.31. You should know the symbol of sodium. They will not give symbol. They will give atomic masses. Right? So 14.31%. Sulfur 9.97%. Oxygen is first hydrogen. Hydrogen is 6.22% and oxygen is equal to 69.50%. Calculate molecular formula. Molecular formula we have calculated. Calculate molecular formula. Assuming that, see what we have to assume. Assuming that whole of hydrogen, complete hydrogen in compound is present as water of crystallization. Molecular mass of compound is equal to 322 gram per mole. So this is the question before us. Read that question once again. There is a compound which on analysis gives 4 elements. They are given their percentage, composition, atomic mass also they are given in bracket. I will not write here because we use that as it is. And then you have to calculate the molecular formula. So first column will be element, next is percentage, then comes atomic mass, then comes relative number of atoms, then comes simplest ratio, and one more is there. I will make space here. That is the simplest whole number ratio. Right? These are the type of table we should make here. First is the sodium. Percentage is 14.31. Yes, 31. Atomic mass is 23. 14.31 divided by 23. This This atomic mass of sodium 23 will be given in bracket. If question comes in examination. In MCQs also they will give atomic masses. Right. Then comes sulfur. 9.97. 32 is the atomic mass. 9.97 divided by 32. Then comes hydrogen. 6.22. 1 atomic mass. 6.22 divided by 1. And then comes oxygen. 69.50. Atomic mass is 16. 69.50 divided by 16. Yes. All entries we have made. Now I have to use the calculator. 24.31 divided by 23 is 0.622. 9.97 divided by 32 is 0.311. 6.22 divided by 1 is 6.22. 69.50 divided by 16 is 4.34. Of course, the smallest is 0.311. 0.622 divided by 0.311. Every number is to be divided by the smallest number. 0.311 divided by 0.311. 6.22 divided by 0.311. 4.34 divided by 0.311. This happens to be 2. This happens to be 1. This happens to be 20. And this is 14. So no need to multiply with any integer. We are getting whole numbers only. To write them as it is. No need to multiply with any number. If we are not getting whole number, then only we have to multiply. But in this case, that doesn't require that step. So we write those numbers as it is. So now we can write empirical formula is equal to empirical formula. Empirical formula is equal to symbol of element and subscript of simple whole number ratio Na2. Yes, H20 O40 subscript to the symbol of element. Molecular mass we have to calculate. So next step is empirical formula. Mass 2 into atomic mass of sodium, atomic mass of sulfur, 20 into atomic mass of hydrogen, 14 into atomic mass of oxygen, 2 into 23, 32, 22 into 1, 14 into 16, 46, 32, 20, and this 14 into 16, 16 fours are 64. 16 1 is 16 plus 6 is 22. 2 to 4. 4, 6, 6, 12. We have 322 here. Right. So N equals to molecular mass divided by empirical formula mass. Molecular mass was given in the question. I heard that, but we already written the question. 322 divided by 322. So 1. So what is the molecular formula? What do I say? Na2 yes H20 O14. What they said? Pole of hydrogen is present in the form of water of crystallization. Right. So 10 water molecules are present. 10 water molecules are present. So just highlight this answer here. From that 10 water molecules, because every water molecule contains 2 hydrogen. 10 H2O I have to separate, extract from it. What remains? Na2, yes, and out of 14, 10 oxygen we have taken. So it is Na2SO4 dot 10H2 is the molecular formula, because they said the complete hydrogen atoms, complete means 20 here, they are present as water molecule, water of crystallization. So 20 hydrogen forms 10 H2O molecule. The remaining is Na2SO4 and that dot 10 H2, water of crystallization, present in a crystal of that salt. Na2SO4 dot 10 H2 is the correct answer there. Right. So lengthy question, but I have deliberately taken some lengthy and difficult question. In examination you get more simple question than this. Right. So we'll go ahead. I hope that you are understanding this, you are writing this just by looking how I am solving. You will not get it. You have to write it completely and solve it at least 2-3 times. Then only you will have idea. I have told you it seems to be very simple when you listen. That is the main property of chemistry. When you listen, it feels very simple, but when you try to express it, you are stuck. You will not able to write it properly because more practice is needed. Now the next question, which is the 4th question in this series. An organic compound analysis give following composition of element. I will make it short now because you not need to write all this. Percentage only, right? Carbon is 57.8%. Hydrogen is 3.6%. And the remaining rest is oxygen. Vapor density. We have written the relationship between vapor density and molecular mass. Vapor density is density of any gas to the density of hydrogen, that ratio. And vapor density is equal to molecular mass by 2. So molecular mass is equal to vapor density multiplied by 2 times of vapor density. Vapor density is given of compound is 83. Determine molecular formula is the question. Yes, you can solve yourself now. 3 questions we have solved. First column is element, second is percentage, then comes atomic mass, then comes relative number of atoms, simplest ratio, and simplest whole number ratio. Right. Yes, 6 columns. There is carbon 57.8. Atomic mass is 12. The hydrogen is 3.61. 3.61, right? 3.6%. Right. Atomic mass is 1. And they said that remaining is oxygen. So oxygen is 100. And from that we have to subtract 57.8 of carbon and 3.6 of hydrogen. Because 3 of them together they makes 100, and that happens to be 38.6, and the atomic mass is 16. 57.8 by 12, 3.6 by 1, 38.6 by 16. This is 3.6. This is 4.82. Right? And this is 2.41. And the smallest one is this one. 4.82 divided by 2.41 is seems to be 2 here. 3.6 divided by 2.4. 2.41 is 1. And this is 1.5, right? 1.49. So this is 2 whole number, 1.5 is not whole number. So it is to be multiplied by 2 to make it whole number. But this also has to be multiplied by 2. And this also has to be multiplied by 2. Yes? Following steps. Right, not at all difficult. Yes, lengthy, but not difficult. We can easily write the empirical formula now, because we know how to write that. The symbol of elements and subscript of the simplest whole number ratio. C4 H3 O2 is the empirical formula. Calculate the empirical formula mass. 4 of carbons are there, 3 of hydrogens are there, and 2 of oxygens. 412, 31, 260, 48, 332, and that happens to be 83. Yes, it is 83, right. Now, molecular mass, they are not given directly, but they said vapor density is 83. So you can say molecular mass is equal to 2 into vapor density, 2 multiplied by 83, and that happens to be 166, right. So N is equal to molecular mass divided by empirical formula mass. 166 divided by 83, that happens to be 2, and that's why molecular formula is equal to empirical formula into N. Empirical formula is C4 H3 O2 multiplied by 2, and it is C8 H6 O4. Yes, this is the molecular formula of that substance. Right, so this fourth question complete. You can pause the video and complete that if you are lagging behind. I will give you 2 questions as a homework. I don't know whether you like homework or not, whether you are solving or not. Just on the faith, on the belief, I am giving this homework. Solve these 2 questions. 2 questions I will give. Question number 5. If the elemental composition, if the elemental composition of butyric acid, common name of acid is used, is 54.2% carbon, 9.2% hydrogen, and 36.6% oxygen. Determine molecular formula. Determine molecular formula if molecular mass of butyric acid is 88. This is one question. See the next one. These are all homework. Question number 6. Carbon 92.3%, hydrogen 7.69%, molecular mass 78, 78. Calculate empirical and molecular formula. So these two questions, and as you are very sincere and very hardworking students, right, isn't it? So I do one more. Carbon 57.8%. Just numbers are different. Methodology is same. Hydrogen 3.6%. Remaining oxygen. Remaining is 100 minus 57.8 plus 3.6. Vapor density 83. Is it the same question which I have solved? Yes. So already we have solved this question. You should not worry about this question. Sorry, we have not solved. So this question is already we have solved. So only 2 questions. But my that stand is constant, that you are sincere and hardworking. Right, so these 2 questions only, you do it. Solve all the numericals, don't postpone the preparation. Every day, 1 hour you have to work on these videos, then only you will understand the concept. So thank you for watching this video.